In this video, we will learn on how to find the volume of a function by using integration method. So, in order to find volume, it's basically follow the same step as in order to find the area, but we have a formula now that's slightly different from before. Alright, so in the question, they will mention whether they want to revolve about x-axis or y-axis. If the question asks to revolve about x-axis, so we rotate about x-axis, our function must be in the term of x, and the limit also depends on x-axis. That's why in this case, our limit is from a up to b. That's basically what lies on x-axis. So from a up to b. And then the formula, in order to find the volume, it must begin with pi. That's the formula. Alright, and then the first function that we encounter from above will be the first formula. So in this case, the first function that we encounter will be fx. That's why we have to put fx here. And then you must put squared. That's the difference between volume and area. Okay. Next part, minus with the second function that we encounter. In this case will be gx. That's why here we have gx. And then once again, squared. But then for the squared part, it must be separate with one another. What I meant here is first function squared minus with second function squared, and not the other way around. Sometimes students might do careless mistake here. They put fx minus gx and then the whole thing squared. And this will be totally different case. And then you might find the wrong volume in this case. So be careful here. Alright. So this is about rotation x-axis. Now, if you want to revolve about y-axis, so the same thing here. So your function must be in the term of y, and then your limit also lies on y-axis. So limit here is, okay, in general, a up to b on y-axis. So our formula start with pi, same as before. And then the first function that we encounter from the right side, in this case is fy. So that's why we have now fy squared minus with the second function that we encounter, in this case is gy. So minus with gy squared dy. Alright, so let's do some question to check our understanding. Okay. So example, we have the curve of y equal to sed x, the line x equal to 4, x-axis from the side of the boundary region. Find the volume if it's revolved about. First part would be x-axis. Okay, so same as before. First step, we must sketch the graph to determine the bounded region in order to find the volume. So I have x-axis and y-axis. Our function will be, the first one is y equal to sed x. So I have here the first function, y equal to sed x. And then we have second function is x equal to 4. I put a straight line here. So that would be x equal to 4. And then x-axis from the side of our bounded region. Alright, so based on these three conditions, you can already determine the bounded region. So we have sed x, x equal to 4, and then last one, x-axis. For sure, the one in the middle will be our bounded region. In this case, I label it as what the question asks for. We have R. Okay, so now we have to revolve about x-axis. So we want to rotate about x-axis. So it comes from above. So we now may start to find the volume. So volume here would be, remember, we have to put pi as our formula at the front. So we have to integrate from above. The first function that we encounter will be sed x itself. So we would have sed x. Don't forget our formula, squared, minus with second function that we encounter. In this case, it happened to be the x-axis itself. So 0 squared dx. So last part, don't forget our limit. So here it stopped at x equal to 4, and y-axis in that case it would be 0. So from 0 up to 4. And now we may start integrate the function. Okay. So pi stay as it is, as that would be the constant. Alright, so first I just simplify it first. We now have sed x squared, and that will be x. minus with 0x, 0 stay as it is. So we only have to integrate x in this case, means that we would have x squared over 2, and our limit is from 0 up to 4. Straight away substitute the limit into the function. Don't forget, start with our upper limit minus with lower limit. So if I substitute 4 here, we will get 4 squared over 2 times with pi at the front. So our final answer in this case would be 8 pi. And unit cube, as we only want to find the volume. So remember, our unit will be unit cube. Okay. So settle with the first question. Moving on. Now, using the same graph, the same function, we want to find the volume if it's revolved about y-axis. Now, y-axis, everything will be different now. So, I just first resketch the graph. Okay. So, we have x-axis, y-axis just now. And then we have our function y equal to set x. And last would be x equal to 4. And then I just highlight back our bounded region here in the middle. And we label it as R. Okay. So now, in this question, we want to revolve about y-axis. So everything must be in the term of y. Our limit also must be on y-axis. But then we have a problem now because we don't know the limit yet. Okay, so our graph begin at x equal to 0. So y also 0. No problem with that. But then we have the problem to find the upper limit. So here, in this case, our x is 4. If I substitute into this function, x as 4, our y value will be 2. That's how we get the upper limit, y equal to 2. Okay, settle with the first part. We already determined the limit on y-axis. Now, we have to rearrange so that our function also must be in the term of y, x in term of y. So, since we have y equal to set x, means that x would be y squared. And only after that, we may start finding the volume. So, for volume, remember, start with our formula. We have pi at the front. And then our limit on y-axis is from 0 up to 2. And then we have two different functions that we have to square and minus together on y-axis. So, the first function that we encountered in this case comes from the right side will be the straight line. In this case, x equal to 4. So, it's 4 squared. Okay. And then the second function that we encounter here will be our curve. And we must use y function. So, in this case, it will be y squared. So, I put here y squared. So, simplify this up before you start integrate. Pi stay as it is. It will be 16 minus y to the power of 4 dy. And then straight away after that, integrate of 16, we get 16y. Integral of y to the power of 4 will be y to the power of 5 over 5. And then copy back our limit. Next part, don't forget, substitute our limit. In this case, we will get 32 minus 32 over 5 pi. Simplify it up once again. Finally, our volume in this case will be 128 over 5 pi. Don't forget your unit cube.